things in this column, what you're actually doing is this right here. So this is what you're going to do to your coordinate points to make those things happen. So the first one here says if you've got an a value right here at the very beginning of your function, what that is causing to happen is a vertical stretch or shrink. So remember, vertical means up and down, right? So if I tell you that we are stretching vertically, our graph is getting tall and skinny, right? So normally, our function like this starts at 0, 0, and then that first point goes up 1 and over 1, right? But if I stretch it, I'm still only going to go over 1, but I'm going to go up more, right? So that's going to make these come closer together because it's going to get stretched tall. If we have a shrink, what's happening is it's getting pushed down or compressed. So I'm still going to go up 1, but I might be going over more, which is going to make this open more like this, okay? And then it says if you have that a value, some a, any number, right, inside of the function, then what this is going to cause is a horizontal stretch or shrink. So that means instead of stretching up or compressing down, I'm stretching to the left and right, or compressing from the sides. I'm compressing in or out. So what that's going to change is how long it takes to complete a cycle, right? So for us, we just said on that assignment we just graded that it took from 0 to 2 pi, right, for you to plot all your points. If we have a horizontal stretch, it's going to stretch those points farther apart, so it's going to take longer than 2 pi to plot your 5 points.
So the first one happens when A is outside, and the second one happens when A is inside.
Correct. And then if we have a horizontal shrink or horizontal compression, what once took 2 pi now takes less. So all my points get closer together. All right? Okay, in addition to that, they also talk about reflections. It says if you have a negative out in front, like this one shows, this reflects across the x-axis. And if you have a negative inside the function, like here, this is going to cause a reflection over the y-axis.
And it just matters if it's a negative, it doesn't matter about the output.
Right, right. Okay, so the way I know if it is a stretch or shrink depends on the value of the number. So like we said, typically for something like this, we might go up 1 and over 1 for our first point, right? If I'm stretching that out, I want to go up more than 1. So if I have a stretch here, that means my A must be bigger than 1. So if A is bigger than 1, I have a stretch, which means that for us to have a shrink or a compression, it must be smaller than 1, right? But when I say smaller, I'm not talking about negatives because remember, negatives do something else. We highlighted that in blue down here. So when I say smaller than 1, I mean like decimals or fractions. So really it would have to be between 0 and 1 for it to be a shrink or compression. All right. Okay, and then if I'm stretching vertically, that's going to affect my y values, right? Because I'm going up more. So a horizontal stretch or compression would be affecting which value then? If this affects my y, this would affect my x, right? Okay, so this is a change to our y value, while this is a change to our x value. Okay. So keeping this information in mind, they want us to discover what exactly this would do to our coordinate points. So yesterday, we plotted the parent function sine and the parent function for cosine. Okay, so we always start at the origin, which is 0 degrees or 0 radians, right? Okay, so if I'm at 0 degrees or 0 radians, that either means I need to think of it as, okay, on my coordinate plane, I'm over here at the point 1, 0. Or, if I'm using my hand, that's this finger, right? And sine is the number of fingers to the right. Either way, how many fingers are to the right? 0, okay? And here, my y value is also 0. So either way, my outcome is 0. Okay? And then when you guys got to the assignment yesterday, I said that you didn't actually have to plot all of the points, right? We said we just were plotting the ones on the quadrantal angles. So after 0 would be up here at 90 or pi halves in radians, right? Okay? So when I'm at pi halves, that would be the coordinate point 0, 1, right? So now my y value is 1 over 1, or if I'm using my hand, that's this finger. Number of fingers to the right is 4. What's the square root of 4? 2. And remember, we always put sine over 2. So 2 over 2 also would be 1. Okay? Next would be over here at this point, which is -1, 0, and that's at pi. So I'm only concerned with the y value, and what's the y value there? 0. Okay? Then I would be down here at this point, which is 0, -1, and that's at 3 pi halves. So if y is -1, what are we going to get for sine? And then finally, the end of the period means I'm back to where I started. So I'm over here at 2 pi, and at 0, it was, so it should be the same at 2 pi, right? Okay, and then I plotted those points up here just to remind us what that looks like. So here's 0, 0. Here is pi halves 1. Here is pi 0. Here's 3 pi halves -1. And here's 2 pi 0. So there's the 5 points it takes to make a cycle, all right? And then it says, for the next line, they want us to make the change of a 2 in front of our function. Well, 2 in front of the function, that would be this rule right here, where it's in front of the function, right? And we said that this would be either a vertical stretch or shrink. Well, since the number is 2, which one's it going to be? Stretch, okay? By a factor of a units. Okay? So that really means if I was originally going up 1 and over 1, right? I want to go up more. I want to go up by a factor of 2, which means 2 times 1, right? So, right here, when it says that we're supposed to be changing by 2, remember we said this is a change to our y value, right? So what I'm going to do here is I'm going to multiply the y by 2. All right, this doesn't affect my x at all. Right? This only changes how much I'm going up and down, which is y. So that means that my x values aren't going to change at all. This is still going to be a 0. And this is still going to be pi halves. And this is still going to be pi. And this is still going to be 3 pi halves. And this is still going to be 2 pi, right? We're not changing anything about the x's. What we said we were going to do is multiply your y values by 2. Okay, so my first y value was 0. Well, what's 0 times 2? Okay, so this one didn't change, right? Okay, my next y value is 1. What's 1 times 2? 2. Okay, and then my next y value is 0. What's 0 times 2? 0. Then my next one was -1, which would be -2. And then my last one is 0, so again, it would be 0. All right. Okay. Next, it says that we have a negative out in front. Okay, so let's go back up here. Negative out in front, that's this rule right here, where it says that means it reflects over the x-axis. So in other words, if I were graphing this, that would mean if I had a point up here, and this is my x-axis, that now that point would be down here, right? Okay, so let's say that this point was at 2, 3. And then I reflect it down here. Where would it be located now? Positive 2, negative 3. Very good. Because it still went over the same amount, right? It just went down instead of going up. Okay? So what's the only thing that changed here then? The y value, right? It changed signs. So basically it was like multiplying it by negative 1. Okay? So that's exactly what we're going to do here. Multiply y by negative 1. So that means, again, none of my x's are going to change. It's still 0, pi halves, pi, 3 pi halves, and 2 pi. The only thing that changes is we multiply all of our y values by 0. So again, I'm going to go back to the original y value. So original y value was 0. Well, 0 times negative 1 is still, right. Going back to that original, which was 1. 1 times negative 1 is negative 1. Again, I go back to the original 0. 0 times anything is still, right. This one was negative 1. Negative 1 times negative 1 is positive 1. And then lastly, this one would stay right. Okay. Okay, and then the last one, they have a 1/2 out in front. So if it's out in front, that still is this very first rule from up here, right? But since it's a 1/2 instead of a 1, that falls in this range, right? Which is what we would call a vertical shrink or compression. But we should still be doing the same thing, right? So apparently I would need to multiply my y by 1/2, right? So again, none of my x values are going to change. I'm just going to go back and multiply all of my original y values by 1/2. Okay, so original y value for that first one was 0. What's 0 times 1/2? 0. Okay, original y value on the next one was 1. What's 1 times 1/2? 1/2. Okay, on the next one, original y value was 0, so it would stay right. The next one originally was negative 1. What's negative 1 times 1/2? Negative 1/2. Good. And then that last one's going to stay 0. Very good. Okay. Now they want us to do the same thing, but for cosine. All right, so let's see. Our original points for cosine. So I still would start at 0 and work my way around the circle, right? So that would be from 0 to pi halves to pi to 3 pi halves, all the way back to where I start at 2 pi, right? So again, I either am picturing that coordinate plane in my head, where we said we start at 1, 0, in which case I would have 1 over 1, or on my hand, 4 fingers to the left is square root of 4 over 2, and square root of 4 is just 2. 2 over 2 still would be 1. So either way, we start out at 1. Okay, and I plotted this one too. We start out at 1, and then when we get to pi halves, where are we at? 0. Okay, and then when we get to pi, where are we at? Negative 1. And when we get to 3 pi halves, I'm back at 0. And then 2 pi, I'm at 1, back where I started. So guys, we want to remember these first 5 points so that way we know what changes to make. So let's try and commit the 5 points for cosine, the 5 points for sine to memory. Okay, so we've got, again, a number out here in front of the function. Okay, so if I have a number in front of the function, that was this first rule up here. And we said that means we have to do what? Multiply what? the y value. Good. Okay, so that's exactly what I'm going to do. Multiply the y value by 2. Okay, so that means our x's won't change. I'm still going to have 0, pi halves, pi, 3 pi halves, and 2 pi. I just need to go multiply all my y values. Okay, so I started with 1. 1 times 2 gives us 2. 0 times 2 gives us, -1 times 2 gives us, and 0 times 2 again would be, right? And then 1 times 2 again is perfect. Okay? For this next one, we've got a negative out in front. Okay, well that would be this one right here, where we reflect across the x-axis. So we said all that really changed here was the sign of y, right? So we said that that meant we were supposed to multiply y by, good. So again, none of my x's are going to change. I've still got 0, pi halves, pi, 3 pi halves, and 2 pi. I'm going to go back to the original. So I got 1 times -1. That would be -1. I got 0 times -1, which would be, right, -1 times -1, +1. And then 0 times -1, and 1 times -1. Perfect. All right, and then for this last one, they've got a 1/2 out in front. So what does that mean we're supposed to do? Good. So multiply y by 1/2. So none of my x's are going to change. Still 0, pi halves, pi, 3 pi halves, and 2 pi. Now we just multiply those x values. Well, 1 times 1/2 would be 1/2. 0 times 1/2 is, -1 times 1/2 is, good, 0 times 1/2, and 1 times 1/2. Perfect. So did we really change anything that we did from sine to cosine while making these changes? Did we change any rules? No. So that must mean that it doesn't really matter if it's sine or cosine. We're still going to do the same thing, right? Okay, so that's what we're going to say here at the bottom. That if we have a vertical stretch or shrink, and remember shrink can be used interchangeably with the word compression, by a factor of a, what this really means that we're doing is multiplying each y value by a. All right? Okay. So if you've got something in front of your function, whether it's a number, a negative, or maybe it's a negative number, you multiply all of your y values by that number. Okay. Flip it over on the back. And we've got one more rule we need to look at. So starting out with sine, well, we already wrote down all of the parent function points for sine on the front. We start at 0. What is sine at 0? 0, 0. Okay. And then what about at pi halves? Good. And at pi? 0. And at 3 pi halves? Good. And at 2 pi? Perfect. Okay. Now we need to make the changes that they're asking about. So this time, they put the 2 after sine, right, inside the function with x. So if you flip back over on the front, when that value is in here with x, that means that we have a horizontal stretch or compression, right? And we said if you are changing something horizontally, you're changing the x value. So I'm not changing y anymore if it's in here. I'm changing x. It also says This is a stretch or shrink by a quotient of A units. What does quotient mean? What operation is that? Division. Right. So instead of multiplying by that factor, they're saying we're supposed to divide by that factor. And I'm not dividing my y values, I'm dividing my x values. Okay. So we are going to divide x values by 2. All right, so that means I'm looking here at my 0. Well, 0 divided by anything is still, okay, so that one won't change. And my y value definitely doesn't change, right? Okay, for pi halves, the way that would look would be pi halves divided by 2, right? But we don't like to see a fraction in a fraction. What do? We multiply by its reciprocal. Or in other words, we call that keep, change, flip, right? So I would keep pi halves, change from division to multiplication, and I flip 2 over. If I flip 2 over, what does it become? 1/2. Okay, and then when I multiply, remember we multiply the numerators. Pi times 1 would give us pi. And I multiply denominators. 2 times 2 gives us 4. All right, so this becomes pi over 4 when I divide by 2. Okay? And I don't change the x value, right? So it stays 1. Okay? Then for pi, I'm supposed to divide pi by 2. So pi over 2. Nothing to simplify there, right? So it would just be pi over 2. And again, the y value doesn't change, so it stays 0. Okay? For this next one, we're going to have 3 pi halves divided by 2. So that's, again, another fraction in a fraction, right? So what am I going to do? Multiply. So I'm going to have 3 pi halves times what? 1/2. So I multiply in the top, and I get 3 pi, and in the bottom we get 4. Okay, so this would be 3 pi over 4, and I don't change the y, so it stays -1. Okay, and then for the last one we got 2 pi. I'm supposed to put 2 pi divided by 2. What's that going to simplify to? Just pi. Good. So I got pi, and then again, that y value doesn't change. Okay, so before, my graph went all the way from 0 to 2 pi. But now my last point is at pi, right? So that would mean I need to take all 5 of these points and smush them closer together. Because now my graph has to stop by the time I get here. So this point is going to scoot over. This point is going to scoot over. This point is going to scoot over. And this one is going to scoot all the way over to here at pi. So they all just got a lot closer together. Okay? So this would be what we would say is a compression or a shrink, right? Because we're pushing them closer together. So we would say we shrunk by 2. Okay? Here we've got 1/2 out in front of x. So again, since it's with x, same rule, right? So even though it's a different number, I still am supposed to do the same thing, which you guys said means I'm supposed to divide all of the x values by 1/2. Good. All right. So 0 divided by anything is still, right, so that one's not going to change. Okay. Then I'm going to have pi fourths divided by 1/2. Okay, well, 1/4 over 1/2, again, we don't like to see a fraction in a fraction. Oh, I'm sorry, pi halves, thank you. Oh, I didn't get the eraser. There it goes. All right, so then I would have pi halves divided by 1/2. And again, we don't like to see a fraction in a fraction. So I'm going to keep my pi halves, change to multiplication, and when I flip 1/2 over, it becomes 2. Yeah, or 2 over 1. So I'm going to multiply in the top, and that's going to give us 2 pi. And I multiply in the bottom, and that gives me 2, which simplifies to pi. And I don't change the y value, so that stays 1. Okay? Same thing here. I'm going to take my pi, and I'm supposed to divide by 1/2. So really, I'm supposed to be multiplying pi by 2, which would give us 2 pi. And I don't change that y value. All right, then we got 3 pi fourths divided by 1/2. So really, I'm multiplying 3 pi fourths by 2. So in the top, what are we going to get? 6 pi. And in the bottom, what do we get? 4, right? Oh, 2. Thank you. I did it again. Thank you. 2. Okay. So if we have 2 in the bottom, can I simplify this any? Yes. That would simplify, yes, to 3 pi. Okay. And then I don't change the y value. It stays -1. All right. So I can work it out the same way for the last one. I can do my pi over 1/2. But also, we might have noticed that there's kind of a pattern here, right? So if my pattern here is telling me that I went from 0 to 1 pi to 2 pi to 3 pi. Any guesses what the last one would be without the work? 4 pi. Which I would get the same thing if I divide 2 pi by 1/2, because really I'm going to keep change flip and get 4 pi here. All right? And again, that y value isn't going to change on us. Okay, so they do have different functions for us depending on where the number is, right? So from here on out, let's say that if it's out in front, we call that capital A. And if we have a number out there in front, what are we going to be doing? Multiplying all of the y values. Okay, so this means multiply y values by A. But it has a different function if it's in the equation, right? Like where this capital B is. So from here on out, let's call it capital B. And what does that B mean we're going to be doing? All right, so divide each x value by B. Good. Okay, so we figured out the pattern. So now they're going to ask us to make a few changes at once. So we're going to do these changes to the graph of cosine. So first, let's start out with what we know the points of cosine to be. So remember, I'm going to start at 0, right? Here's my picture of cosine. At 0, what are we at? 1. And then I'm at pi halves. When I'm at pi halves, I'm at 0. And then when I'm at pi, I'm at -1. And when I'm at 3 pi halves, 0. And then when I'm at 2 pi, I'm back at 1. Perfect. So I'm going to make these changes to this graph. So this one says we need to do a couple things, right? We've got this -2 out front, which means we're going to do what? Multiply the y's. Good. Okay. So multiply y by this number. And then I also have this 3 right here, which tells me we are going to divide x. Good. All right, so we got to do something to x and y this time. Okay, so I am going to take my 0 and divide it by x, right? Or divide it by my x value, which is 3. Well, 0 divided by anything is still 0, okay? All right, y value. I'm supposed to multiply it by -2, but again, 0 times anything is just, oh, sorry, it's 1. We're not doing sine. We're doing cosine. 1 times -2 would be -2. All right, so that one did change my y. Okay, for pi halves, pi halves, I'm supposed to divide by what? 3. So that'd be pi halves over 3. What's that going to look like if we keep change flip?
It's 3 pi halves.
Right. Because I'd have here, oh, sorry, not 3 pi halves. It would be pi over 6. Yeah, because we have to flip the 3 over when we multiply. So pi over 6. Okay. For my y value, now I've got a 0. 0 times anything is still just 0. Okay, so that'll stay 0. All right, for pi, on the next one, I'm supposed to divide pi by, which would be pi over 3. Okay. And then my y value, I'm supposed to multiply by negative 2. Negative 1 times negative 2 would be 2. Okay? Then we've got 3 pi halves. So I'm supposed to take 3 pi halves and divide by 3, which really means 3 pi halves times a third, right? So what's that going to give us? 3 pi over 6. Can I simplify 3 pi over 6? Pi over 2, right? All right, and then 0 times anything just stays, right? Then lastly, we got 2 pi that we're supposed to divide by 3. So this time I don't have a fraction and a fraction, so I can leave it like that, right? So 2 pi over 3. And then for my y value, 1 times negative 2 is perfect. Okay, so now I've got my new points. I'm going to come down here and plot those points on our graph. So my first point is at 0, negative 2. So I got a point down here. I'll do it in red so you can see it better. At 0, negative 2. And it would appear each one of these lines must be worth pi 6, right? So if I am going pi 6, 0, I'm just moving over one line and plotting myself a point here at 0. Okay. Pi thirds, that's the same as 2 pi 6, right? So that means one more line over. And I'm supposed to have a point up here at 2. Okay, and then I'm at pi halves 0. And then I'm at 2 pi thirds, negative 2. So one more line over, and I'm back here. All right, so if I were to connect these points, this is one full cycle of cosine. Okay, so normally cosine looks like this, right? It starts at a maximum, but we had a negative in front, which we said would reflect it, right? So that's why it starts down at the bottom now, okay? And we also said because of it being a 2, that it stretched it up tall, which is why this one's stretched tall and skinny. And we had a 3 in there that we said was going to squish it all closer together too, right? That compressed it. Okay, so if I wanted to continue this pattern, I could. I can show that there's more points, right? And it's just going to continue that same look, right? But I'm only requiring we have those 5 unless it tells you to continue to a specific point, okay? So then they ask us what we see in this graph. Domain. Domain is my x values. Is this thing ever going to stop going to the left or right? So that would be right, or all real numbers. Okay. My range. What's the highest that this graph is ever going to go? And what's the lowest? Okay, so we would say it's between negative 2 and 2. So you would either write that as negative 2 is less than or equal to y is less than or equal to 2, or negative 2 to 2 with the brackets, right? Okay, and now they ask for the period. Well, previously, our period, it took 2 pi to get through the whole thing. But today, we just saw that for this one, it only took from 0 to where was the last one? 2 pi thirds. So that must mean that the period is only 2 pi thirds long instead of 2 pi like it was previously. All right? Okay. All right, tomorrow we are going to do